In this video, we're going to look at light and how we see different colors. Here we have white light, and we're going to pass it through a glass prism like this, which is going to cause the white light to split into its different wavelengths. So white light is actually composed of all these different wavelengths, a range of wavelengths, which we call the visible spectrum. In this example, white light is directed at a whiteboard. Describe and explain what the person will see. So we saw that white light is made of lots of different wavelengths of the visible spectrum. And so there's lots of different colors. And white objects are really good at reflecting all of this. So they're going to reflect all these wavelengths, and that's going to go into the person's eye. So the person will see all these different wavelengths. So the person will see white light. Now, when you're describing this, you have to use the word reflect to describe what's going on. Okay, in example 2, an apple is placed under a lamp which is emitting white light. Describe and explain what the person will see. So we saw that white light is made out of a range of wavelengths which make up the visible spectrum. Now when it hits the red apple is going to absorb all the different wavelengths except red. So the key word here is absorb. Okay, so it's going to take in all that energy, except for the red wavelength, which it's going to reflect. And that reflected wavelength is going to go into the person's eye, and the person will see the apple as being red. Example 3 here, we have white light which is directed at a black kettle. Describe and explain what the person will see. So we saw that white light is made of all the different wavelengths of the visible spectrum. When it hits this black object, the black object is actually going to absorb all the wavelengths. So nothing is going to be reflected into the person's eye. So there's no light going to the person's eye. So actually that's what the appearance of black is, when there's no light going into your eyes. So it appears black. Example 4. A blue filter is placed in front of a white light at the position marked X. Describe and explain what the person will see. So remember, white light is made of all different wavelengths and it's going to hit this blue filter. But the blue filter is actually going to absorb most of the light, all the wavelengths, except for blue, which it's going to allow to pass through. We say that the blue gets transmitted through. The wavelength corresponding to blue is transmitted through. So make sure you use words like absorb and transmit. Now when the blue wavelength light hits the red apple, is going to get absorbed. So the blue light is going to get absorbed by the red apple, so nothing is going to get reflected off the red apple. So the person won't see any light going to the person's eye. So the apple will actually appear black to the person. Example 5. The blue filter is now moved to the position marked Y. Describe and explain what the person will see. So all the different wavelengths from the visible spectrum is going to be incident on the red apple. The red apple is going to absorb all the wavelengths except the one corresponding to red light, which it's going to reflect. So the red light is getting reflected, and now it's going to try to go through the blue filter. However, remember, blue filters only allow wavelengths corresponding to blue light to pass through. So none of the light is going to be passed through, it's going to get absorbed. So the person will, well, there's no light going to the person's eye, so it will appear black because there's no light there. Okay, final example, white light is directed at a red filter which is in front of a whiteboard. Describe and explain what the person will see. So when we shine the white light through the red filter is going to absorb all the wavelengths except for red. It's going to allow the red wavelength to pass through. So we say that red wavelengths transmitted through the red filter. And then when it hits the whiteboard, remember white is good at reflecting all the different light wavelengths. So it's going to reflect the red that's hitting it. And the red light is going to go into the person's eye. So the whiteboard is actually going to look red because of the filter and what's being reflected from the whiteboard.